Hi students, welcome back to my second class. Today I will explain you about law of chemical combinations. Okay, so what do you mean by law of chemical combinations? See, whenever two or more atoms, when they are reacting to form molecule or compound, sometimes we discussed it about in my first class, that is classification of matter. So whenever atoms combine to form molecule or compound, they follow certain basic principle of law of chemical combinations. That means they follow certain basic principle with respect to their ratio of their masses, ratio of their volumes, etc. for chemical combinations. So these basic principles we will now study in terms of law of chemical combinations. So there are 4 laws of chemical combinations. The first law of which is called law of conservation of mass. Okay, let us see what is law of conservation of mass. So what do you mean by law of conservation of mass? So we have been studying this for a long time. From our primary classes also we know that matter or mass can neither be created nor destroyed. What do you mean that? We studied it, but let us see with examples and let us apply it so that we will understand more what exactly we were telling that time. See, mass can neither be created nor destroyed. That does mean if I will explain you or if I will define it in another term, I can say that during any chemical changes or during any chemical reaction, the total mass remain constant in the system or throughout the system. So I can write the definition now. During a chemical change, the total mass of the system remain constant. Means, if I will give an example here, let us say there are 2 atoms combined here, let us say A and B combined here to produce C plus D. That means let us say this is reactant, this is product. What the law of conservation of mass tells here is, let us say at the initial stage the reactant mass is, let us say, some 10 gram. Before reaction the reactant mass is 10 gram. Then after completion of the reaction, when the product is formed C and D, then the total mass will also be 10 gram. That means once the reaction is completed, here the reactant mass will become 0 now. 0 now because all reactants are consumed here and the product is produced. Here the product mass will be 10 gram. That means before the reaction, mass of the reactant before reaction is equal to mass of the product after reaction. This is called law of conservation of mass. If I will explain you little more clarity, if I'll give my explanation, then I can tell that let us at the initial stage, again let us say the reactant mass is 10 gram. Before the reaction occurs, the product mass will be 0 gram, correct? Because reaction has not occurred still, the product is not produced. So at the beginning, let's say the reactant mass is 10, so at the beginning the product mass will be 0. So the total mass, the reactant mass and product mass will be 10 plus 0 is equal to 10. Now let us say the reaction takes around 10 seconds to complete, okay? So let us say after 5 seconds or 6 seconds, we will measure the mass of the reactant and product again. Let us say the reaction takes 10 seconds totally, but after 5 seconds or 6 seconds, let us say, we'll measure the mass. Let us consider out of 10 gram, 6 gram mass of the reactant is consumed. Then what will be the mass of the product produced in this case? If 6 gram is consumed, here 6 gram will be produced. In this case, the remaining mass of the reactant will be 10 minus 6 is equal to 4 gram, whereas the mass of the product is 6 gram. If we add at 5 second interval, then here the mass again will be 4 plus 6 is equal to 10. Again, the mass of the reactant and the mass of the product, total mass is remain constant 10 gram, 10 gram. Now let us say after completion of the reaction, again we measure the mass. Let's say the reaction completes after 10 seconds. Let you measure again. Once the reaction is completed after 10 seconds, here what will happen? The mass of the reactant will be 0. Because once the reaction is completed 10 gram it will consume. So the reactant mass will be 0 gram here. Now once this is 10 gram is consumed, here it will produce in the product total 10 gram. So the reactant's mass now after completion of the reaction is 0 gram, where the product mass will be 10 gram. Now again if we add reactant's mass and product mass, it will be 0 plus 10 is equal to 10. Now again the total mass of the system is 10 gram. So all the three cases the mass of the system is 10 gram only. This is called the law of conservation mass. That means the mass of the system remain constant throughout the system whenever you measure. Clear? Take an example. Now let us say carbon is reacted with oxygen to form carbon dioxide. Here let us explain how the law of conservation of mass applies here. Let's say here 1 mole of carbon means the atomic mass of carbon is 12, so the gram atomic mass will be 12 gram. Here the atomic mass of oxygen is 16, so there are 2 atoms of oxygen, so it will be 32 grams gram atomic mass. Now we have to show that these 2 added together will be how much? 44 gram. So now we have to see whether it is 44 or not. Again here the mass of carbon is 12 gram atomic mass plus 2 oxygens, so it will be 32 gram. So the whole mass will be again 44 gram. So the mass of the reactant before the reaction is 44. The mass of the product after the reaction is 44. So it is mass of the reactant is equal to mass of the product, which obeys the law of conservation of mass. Clear? Now I will take one numeric problem here to explain you what is law of conservation mass. Okay? So here let us say one problem is given. The question is 3.4 gram of silver nitrate, AgNO3, silver nitrate solution, when reacted with when reacted with 1.17 gram of sodium chloride solution, then 1.7 gram of sodium nitrate and some amount of silver chloride AgCl formed. Find the mass of AgCl by applying law of conservation of mass. Okay. Now with this problem, let us apply the law of conservation of mass and find the mass of AgCl. So now what I will do is, here I will write the reaction. What the reaction tells here is silver nitrate is reacting with sodium chloride to form AgCl, then sodium nitrate. Okay. Now let us say AgNO3 plus sodium chloride. I am writing the reaction. It forms AgCl, silver chloride plus sodium nitrate, NaNO3. Now what is given here? Data 3.4 gram of AgNO3. So it is 3.4 gram. Sodium chloride is 1.17 gram. AgCl, it is asked how much mass. So let us take as X. AgCl is, now this is given how much? 1.7 gram. Now in order to find here, I can say 3.4, 1.17, so it will be 4.57. This is added together, I will get 4.57 gram. Now this will be X plus 1.7 gram. Okay. Now the value of X is equal to 4.57 minus 1.70. So it is equal to 2.87 gram. Clear? फटाफट लिख लीजिए. Now the second law here is law of constant or definite proportion. Law of constant, or we can call definite proportion. Definite proportion. What do you mean by law of definite proportion or constant proportion? This law tells that a chemical compound, whenever obtained from whatever source or method, it has the same chemical composition. That does mean a chemical compound may be formed by any source or any method. Does not matter. Irrespective of the source or method, it should contain the same chemical composition with respect to their masses. Okay. We have seen some compound we can form by different method. If I take an example of carbon dioxide, let us say carbon dioxide is present in air naturally, correct? This is one. We can prepare carbon dioxide also by, our laboratory process or our synthetically. Let us say I will take an example of carbon dioxide preparation. One method, let us say, first method, one is when calcium carbonate is heated, limestone or calcium carbonate is heated, then we get carbon dioxide and calcium oxide. So carbon dioxide is produced here, correct? So calcium carbonate, when I heat it, I get carbon dioxide equals calcium oxide here. Now let us say another method of preparation of carbon dioxide. I can say, let us say, if calcium oxide, let's say carbon reacted with oxygen, then we'll get carbon dioxide as well as, correct? When carbon is burnt in oxygen, we get carbon dioxide here also. This is another method of preparation of carbon dioxide. Second method, let us say. Second, this is first. So what the law of constant and definite proportion says is, here this is one method of preparation of carbon dioxide. Here the composition of carbon and oxygen, if you will see in carbon dioxide, see, carbon is 12, oxygen is 2 into 16. So there are 2 atoms of oxygen, 32. So the ratio of carbon and oxygen here is 12:32. If I simplify it, I will get it 3:8. If I take about the second example, this is also another method of preparation of carbon dioxide. Here also, if I see the ratio of carbon and oxygen, again I will get 12 only. Here also 2 into 16 is 32 only. So here also 12:32 case, so 3:8. So I have taken 2 different methodology of preparation of carbon dioxide, but in both cases, the composition of carbon and oxygen in the carbon dioxide makes a same ratio. Both cases the ratio is same. The ratio of their masses is same, 3:8, 3:8 only. If I take carbon dioxide sample from air also, that carbon dioxide also, the ratio between carbon dioxide is 12:32 only. This will also make 3:8. That is also 12:32. So does not matter whatever sources or whatever methodology we have applied to form or obtain a chemical compound, its chemical composition will remain same. This is the law definite or constant proportion tells. Now let us take an example with a numeric problem, so it will be more clear. Let's say I'll take a numeric. It says, the problem says that a sample of limestone is heated to produce 5.6 gram of calcium oxide, in which oxygen content is 1.6 gram. This is one method given. Another method is given. Two gram of oxygen is burnt with calcium metal to form 7 gram of calcium oxide. Now it is telling that there are 2 sources given here, 2 methods given. Now it is telling that proof that this is obeys the law of definite proportion. So what the first one is, if I'll take the first one and second one, case of first and second, let's say first case, let's say second case. In the first case, it is given the mass of calcium oxide mass is 5.6 gram, and the oxygen mass, how much, is 1.6 gram given. So here, can we find the mass of calcium here? Of course, the oxide mass is 5.6, the oxygen mass is 1.6. So when we subtract the oxygen's mass from the oxide mass, the metal mass will be find out here. Okay, let us find out. Mass of calcium is 5.6 minus 1.6. Okay, this is will get 4 gram. So here the mass of oxygen is 1.6 and mass of calcium is 4 gram. If I take the ratio of calcium and oxygen here, calcium and oxygen ratio, then here I will tell 4 is to 1.6, then I will get it here 2.5 is to 1. Here the ratio of calcium and oxygen is 2.5 is to 1. Now we have to prove in the second case also the ratio of calcium and oxygen is this. Then we can tell that these two methods obeys the law of constant and definite proportion, because here calcium oxide is prepared in one of the method, here calcium oxide is obtained in another method. So the ratio of calcium and oxygen is here this. If we prove in the second method also the ratio between calcium and oxygen is this, then we can say it obeys the law of constant and definite proportion. Let us see in the second part, how much calcium oxide is given in the second part? It is 7 gram. How much oxygen is burnt? 2 gram. So what is the mass of calcium? Is equal to 7 minus 2 is equal to 5 gram. Now if I take a ratio of calcium and oxygen here, then calcium is 5 but our oxygen is 2. So what is the ratio? Now if I tell, I will get 2.5. So the ratio of calcium and oxygen here is 2.5 is to 1. Here is also 2.5 is to 1. This is what the law of constant and definite proportion. Clear? Now the third law will see the law of multiple proportion. Okay? Now if we will see law of multiple proportion. Multiple proportion. What is it? Law of multiple proportion. Law of multiple proportion tells that whenever two different elements combine to form two or more compounds. Please remember, when two elements combine to form two or more compounds, then the different mass of one element which combines of other element bears a simple ratio to one another. Anything understood? No, huh? So let me write the definition of the law of multiple proportion first. Then I will explain. I will take an example so it will be very clear. Okay. Now I told whenever two elements combines to form two or more compounds, then the different mass of one element which combines with fixed mass of other element bears a simple ratio to one another. Let me take one example. When two element, let's say two element, one element B another element. When two elements combines to form two or more compounds, let's say these two elements are combined, A and B, and let's say we form two or more compounds. Let's say A1B is one compound, A2B is another compound. Two compounds. Then the different mass of one element. So let's say masses of A is different here. That's why I written A1, A2, A1, A2. Let's say the masses of A is different here. Combined with fixed mass of other elements. So B mass is fixed here. Then what is telling that when the B mass is fixed here, then if these masses, which are different masses here, if you take a ratio of these different masses here, A1, A2, this must take a simple ratio or bear a simple ratio, maybe 1:2, 2:3, 1:3, like it should maintain a simple ratio to one another. This is what the law says. If I take an example of chemical compound, I'll take same example. Let's say carbon and oxygen. There are two different elements. If they two combines, we may get carbon monoxide in one case. Another case we can get carbon dioxide also. The two different compounds can be formed with help of carbon and oxygen. We can form two different compounds, carbon monoxide and carbon oxide. When we supply limited supply of oxygen with carbon, then we'll get carbon monoxide. When we supply excess of oxygen to carbon, to burning the carbon, we'll get carbon dioxide. Okay, limited supply, we can form carbon monoxide. Excess supply, you will get carbon dioxide. Here, two elements combine two different compounds, correct? So the different masses of one element will combine with the fixed mass of other. Different mass here, what? Oxygen, here 1, here oxygen is 2. So this is different masses. The fixed mass here is carbon. If fix the mass of carbon here, then the different mass is oxygen here. If you take a ratio of this element, O is to O2 here, that means the atomic mass O is 16 here, and here is 2 oxygen atom is there, so 2 into 16, 32. That means if I simplify it, I will get 1:2. This is what the law of multiple proportion tells, that it bears a simple ratio. So 1:2 is a simple ratio, correct? If I tell a very good example now, another example, let's say nitrogen and oxygen reacted. Nitrogen and oxygen reacted. When nitrogen and oxygen, we may get variety of compound. Okay, let's see the compounds form. N2O, N2O2, N2O3, N2O4, N2O5. These are the 5 types of compound. When nitrogen reacts with oxygen, we can get it. Here, of course, see N2O2, I can simplify it and can write NO. Here, N2O4, I can simplify and write NO2. But does not matter. I have written here it to make our problem more easy and to make you more clear. I have written it in this form. Does not matter, okay? Now here, let us say in the first case, if I take the ratio of nitrogen and oxygen, see nitrogen's atomic mass is 14, oxygen's atomic mass is 16, we know. So nitrogen, there are 2 atoms of nitrogen, so it will be 28 versus 16 in the first case. If I see that oxygen 16, so nitrogen and oxygen ratio here is 20:16. Here again 28. Here 2 oxygens are there, so 16 into 2, 32. Here N2O3, nitrogen fixed here 28, it is 48. 3 oxygen atoms are there, so 16 into 3, 48. Now next is here 28 again nitrogen, because N2, this is 16 into 4, 64. Now it is N2 again 28, so it is 605, 16 into 5, 80. Now here the mass of nitrogen remain constant, all are 28. If I take a ratio of oxygen in all cases, so 16, 32, 48, 64, 80, I will get 1:2:3:4:5, which is a simple ratio. Clear? So I will take a numeric problem quickly. So here let us see this numeric problem. Copper reacted with oxygen to form two different compounds, cuprous oxide and cupric oxide, with the following data. The data is given: copper when reacted with oxygen, two types of oxide is formed. One is cuprous oxide and another cupric oxide, with the following data. The first one is given: 0.89 of copper react with oxygen to form 1 gram of cuprous oxide, whereas in the second case, 0.8 gram of copper react with oxygen to form 1 gram of cupric oxide. Now it is telling that proof that this obeys the law of multiple proportion. So let us say, again I will take first, second. Here mass of copper, how much? Copper is 0.89 gram, whereas the cuprous oxide Cu2O is 1 gram. So what will be the mass of oxygen here? Oxygen mass is, if you will subtract here 1 minus 0.89, then I will get 0.11 gram. This is the mass of oxygen. Okay. Now if I take the ratio of copper and oxygen here, then I will take the ratio of 0.89 is to 0.11, then almost I will get 8:1. I got 8:1. Here I have taken the copper's mass given is 0.89, and cuprous oxide mass is 1 gram. Then I found oxygen's mass, subtract it, I got 0.11, then the ratio I have taken 8:1. In the second case, it is given that copper mass is 0.8 gram, then here cupric oxide mass is given is 1 gram again. Okay, now I can find oxygen's mass of oxygen, then I will take 1 minus 0.8 gram, then I will get 0.2 gram. If I take the ratio of copper and oxygen here, then I got 0.8 is to 0.2, then I got copper and oxygen is to be 4:1. Now here we got copper and oxygen ratio is 8:1. Here the copper and oxygen ratio is 4:1. Okay, so these two bears a simple ratio. If I find here how, if the oxygen's mass is constant here in both cases, 1 and 1. See here copper versus oxygen, copper is 8, oxygen is 1. Here copper is 4, oxygen is 1. So keeping the mass of the oxygen constant here 1:1, if I take the ratio of copper here and here, copper versus copper, then I got 8:4, which is 2:1, which is bears a simple ratio. So this is what the law of multiple proportion tells. Clear? Now we'll last law of reciprocal proportion. Okay, now the last law, the fourth law is law of reciprocal proportion. Okay, what the law of reciprocal proportion says? It states that whenever two different elements combine separately with a third element of fixed mass, then the ratio of the masses in which they bear so will be same or will maintain a simple multiple ratio if they combine themselves separately. कुछ समझ में आया? Looks very complicated, correct? I will make your life easy. let me write the definition first, then I will explain with example, correct? Law of reciprocal proportion. When two different elements combines with a third element separately, then the ratio of masses in which they bear so will be same or will be a simple multiple ratio if they combine themselves separately. This is when two different elements combine with a third element separately, then the ratio of masses in which they bear so will be same or will be a simple multiple ratio if they combine themselves separately. Now, let me take when two different elements, let's say A is one element, B is another element, let's say they combine with a third element C of fixed mass, then let us say there are two different compound formed A, C and B, C. Then let us say here, because here the mass of the C is fixed, CC, here if I take the ratio of A and B, what the law is saying is, here whatever the ratio of A and B is coming, this ratio will be either equal or simple multiple to the ratio of A and B if I take here between these two. That means if A and B combine separately, then whatever product will be formed, let's say AB, here I will take the ratio of AB here, then this ratio A is to B and this ratio A is to B. Either these two will be same or both will maintain a simple multiple ratio to one another. This is the law of reciprocal proportion. If I take an example, let's take sulfur is one element, oxygen is another, let both combine with hydrogen separately, then there are two products will be formed. What? One is, let's say H2S, another is H2O. Possible, correct? Both compounds. Then what here, if I keeping the mass of hydrogen is constant, both case the H2S2, if I take a ratio of sulfur and oxygen here, the atomic mass of sulfur is 32 and the atomic mass of oxygen is 16. So the ratio I will take sulfur is to oxygen is 32 is to 16 is 2 is to 1. In this case, sulfur and oxygen ratio is 2 is to 1. Now let us check when sulfur are here, sulfur and oxygen are reacted separately. If it reacts then it will form a product called sulfur dioxide. Okay. If I take a ratio of sulfur and oxygen here also the mass of sulfur is, atomic mass is 32, and here there are 2 atoms of oxygen is there, correct? So one atomic mass of oxygen is 16, so there are 2 oxygen atoms are there, so 2 into 16 is 32. So here the ratio between sulfur and oxygen ratio is 32:32, 1:1. Here the sulfur and oxygen ratio is 1:1. Here sulfur and oxygen ratio is 2:1. These two maintain a simple ratio to one another. If I take a ratio of ratio, that means here sulfur and oxygen ratio is 2:1. Here sulfur and oxygen ratio is 1:1. So if I take a ratio of ratio 2/1, 1/1, then again it will be a 2:1, which maintains a simple ratio to one another. This is the law of reciprocal proportion talks about. Now let me take a numeric problem for law of reciprocal proportion quickly. The problem is here, let's say potassium chloride KCl contains 52% potassium. Again it is given potassium iodide contains 23.6% potassium. Another case is given ICl contains 78.2% iodine. With this data, it is asking proof that this follows or obeys the law of reciprocal proportion. So let us see. Here I will see potassium chloride here contains how much? Content of potassium is 52%. Potassium is 52%. Here then what is the content of chlorine? It is 52%. If I subtract it from 100, then it will be 48%. So chlorine will be 48. Okay. Now here potassium iodide. Potassium iodide, how much it is given? In potassium iodide, potassium content is given 23.6%. So what is the percentage of iodine it will be here? So it will be, iodine will be, if I subtract from 100, it will take some 73.4. Correct? 76.4. Correct? Now, here the content of potassium is 52, chlorine is 48. Here the content of potassium is 23.6 and the iodine is 76.4. Now, if I try to fix the content of potassium in both the cases, let us say I will bring here the potassium here. Here the potassium content is 52. Here the potassium content is 23. Let I bring here potassium is 52, first case and second case. Contains 52% here and chlorine is 48 here. Now what I will do is I will try to maintain the potassium content constant so that it will be easy to make a ratio between chlorine and iodine for me. Correct? So in order to make the potassium constant, let me try to make it the potassium content of the first cases into 52%. If once this both will be 52%, then I will take a ratio of chlorine and iodine. In order to make it 52, if I can multiply here with a constant of 2.2, then it will become 52. So the first case is here, this if I can convert into 23.6 and I will multiply with a constant 2.2, it will become 52%. If I multiply here with the constant of 2.2, then I have to multiply the same factor here, to make the ratio same. So here, then the iodine will become, see how much it will come, iodine will come around 172.75. 172.75. What I did is, here I made the potassium content both cases fixed. So accordingly the iodine content is multiple of 2.2. So it will become 172. Correct? So in this case, here, now the potassium content remain constant. So if I take a ratio of chlorine versus iodine here, how much it will come? 48 versus 172.75. This I will take, if it make it, then simple, I will get it 1:3.6. So chlorine versus iodine is 1:3.6. Now the another data is given here in ICL. Iodine content is given is 78.2%. So if I find chlorine content here, if I minus from 100, then I will get 21.8% chlorine. Now if we take a ratio of chlorine and iodine, in this case, chlorine is to iodine, then 21.8 78.2. This case also I will get, if I make it simplify, I will get 1:3.6. So in this case, the chlorine and iodine ratio here and the chlorine and iodine ratio by this remain same, 1:3.6, 1:3.6. This is obeys the law of reciprocal proportion, because here both cases it is same, because law of reciprocal proportion says whether it should be same or it will be a simple multiple ratio to one another. So here in this case the ratio becomes same, chlorine versus iodine, chlorine versus iodine. So this obeys the law of reciprocal proportion. So dear students, thank you very much. Today's class is over. If you like my video, kindly hit the like button. Please share my video to others. Also subscribe my channel. Thank you very much for watching. Bye bye. Kindly wait for my another video which is coming shortly. Bye.